Hello everybody! Today I can dilate lines not centered at the origin by determining if the point is on the line. This is the second lesson in line dilations. We have our song, which I'm going to play shortly. Line dilations, parallel, keep the slope. So when you're doing a line dilation, it's always parallel. Whenever I dilate a line, it's always parallel, which means the slope is always the same. What we're going to do today is we're going to determine if the center is on the line. To do that, I'm going to substitute x and y into the equation. If it works out, it's on the line. If not, then it's off the line. If it's on the line, it has the same y-intercept. If it's off the line, it has a different y-intercept, and we'll learn how to find that y-intercept today. And then last class, we talked about if it's the origin, you're multiplying scale factor in B. There's a lot of little components to this lesson. A lot of students have trouble with this regions-wise, just because there's a lot of little things, but if you know your song, everything's in your song. Speaking of the song, let's go through our song now. So let's go to Schlansky.com. Let's go to my YouTube channel. I got 300 subscribers. Woo! Took me long enough. Playlists, Common Core Geometry songs. This will also be on your SAT song, because like I said yesterday, it's a very commonly... No, I'm sorry, this is not. I was thinking of something else. No, this is not a commonly asked SAT question. Line dilations. Enjoy.
Line dilation.
No!
Line dilation. Parallel, keep the flow. Sector on the line, sub X and Y on the line. Same beat, off the line, different origin, multiply, scale, factor, and speed.
Alright, so... We'll save that for another time. So, number one. Dilate y equals 2x minus 1 by a scale factor of 2. Line dilations, parallel, keep the slope. I know I'm going to keep the slope. Center on the line, sub x and y. I am going to determine if the center is on the line by substituting x and y into this equation. So, y is 3, x is 2. 3 equals 4 minus 1. 3 equals 3. Therefore, it's on the line. On the line. Same B. Same B. Same M. Same B. Same equation. If the center of dilation is on the line, it's the same line. I'm going to show you why now. But this is the procedure I want you going through, but I'm going to show you why it's on the line. Why it's the same now. So if I graph this line, y equals 2x minus 1. Let's make this a little bit bigger. Y-intercept is negative 1, slope is 2. And so here's how I would dilate it. It's centered at 2, 3, which is right here. So let's say I want to dilate this point right here. Well, I count from the center to that point. It is down to left 1. Do that twice. Down to left 1 once. Down to left 1 twice. It becomes that point. Let's do another point. Let's dilate this point. It's down 1, 2, 3, 4, 1, 2. Do that twice. 1, 2, 3, 4, 1, 2. 1, 2, 3, 4, 1, 2. It's that point. It's the same line. If the center of dilation is on the line, then the image will fall on the same line. So that's why we determine to see if the point is on the line by substituting x and y. If it is, it's the same line, same b, and it always, no matter what, has the same m. Now number 2 is very similar. Again, it's 2x minus 1. So let's go through this like I'd be going through this on a test. Line dilations, parallel, keep the slope. Center on the line, sub x and y. So I'm replacing y with 2 and x with 2. It is not on the line, which means it's going to have a different y-intercept. Now, for the Regents questions, that should be enough. That should be enough to get the question correct. It'll usually just say, is the y-intercept the same or different? Is the slope the same or different? But we'll go a step further and actually do it. But what I'm about to do, Regents-wise, outside of today, we're really not going to do it. I'm just going to ask you if the y-intercept is the same or different. But here's how I would do it. Again, let's start by graphing the line. The center of dilation is 2, 2. So let's dilate a couple points. So let's do this point right here. So to get from the center to that point, I'm going up 1. So I'm going to do that twice. Up 1 once, up 1 twice. Let's pick another point to dilate. Let's do a different color for the next point. Let's do red. Let's dilate this point. So to get from the center to that point, it's down 1, left 1. Do that twice. Down 1, left 1 once, down 1, left 1 twice. Now I draw a line through those points. What's the y-intercept of that line? 0. So the slope is 2, the y-intercept is 0, y equals 2x. Again, if you don't get that, getting the y-intercept exactly, it's not the end of the world. I'm really more concerned about you understanding if the center is on the line, it's the same b, it's the same equation. If it's not on the line, it's a different b. If I want to find the b, I would have to find the new line by dilating the points, just like I did in that lesson that we did when we dilated shapes. Once I have 2 points, I can draw the line. Once I draw the line in, I can find the y-intercept. Number 3. Line dilations, parallel, keep the slope. Center on the line, sub x and y. 1/2 times 1 is 0.5 plus 4 is 4.5. It is not on the line. So I know that it must have a different b. That's really what I'm most concerned about. If I want to find b, here's what I would do. I'm going to graph the original line. Y-intercept is 4, slope is 1/2. I am going to, my center is 1, 6. I'm going to pick a couple points and I'm going to dilate them. Let's do this point. To get from the center to that point, I'm going down 1, right 1. Do that 3 times. Down 1, right 1, 1. Down 1, right 1, 2. Down 1, right 1, 3. I mean, really, all I need is 1 point. Now that I have that 1 point, I know the slope must be 1/2, so I can just kind of apply my slope of 1/2. I need the y-intercept, so I'm going to go back towards the y-axis. the y-intercept is 1. The slope is always the same as the original, so it's going to be y equals 1/2 x plus 1. Let's go to number 5. Little twist. Line dilations, parallel, keep the slope. Well, I'm going to have to first get y by itself. So my slope is going to be -1. Center on the line, sub x and y. It doesn't matter if you sub it into the original or the one with y by itself. It just doesn't matter. Y is 6, x is -1. They are not equal, so it's got to have a different b. And again, that should be enough to answer the questions in the regions, but we're going to now find the b by graphing it. -x plus 3. The center is -1, 6. So all I really need to do is dilate 1 point. So let's do this one. It's down 2. Do that twice. Down 2. Down 2 more. It ends up there. The slope is -1. So I apply my slope of -1. The y-intercept is 1. Y equals -1x plus 1. All right. Number 6. Start by getting y by itself. I'm going to have you start doing it. Take about 10 seconds. Get y by itself. All right. Take about 5 seconds. Tell me the slope. Line dilations, parallel, keep the slope. The slope is the same. Next, I have to determine whether or not the center is on the line. To do that, I'm going to substitute x and y. So I want you to take about 30 seconds and determine if the center is on the line. To determine if the center is on the line, I'm going to sub x and y. So it's going to be 6 equals -3 times 0 plus 4. 6 equals 0 plus 4. Nope. So therefore, it has to have a different b. Now this one's kind of easy because this is telling me the y-intercept. The y-intercept 6, 0, 6 is the y-intercept. Oh, I'm sorry, I take that back. That's what the center of dilation is. No, I'm sorry, I take that back. I got to do this. Y equals -3x plus 4. So let's graph -3x plus 4. Kind of hard to write in this thing. And the center is 0, 6. So I'm going to pick this point. it's 2 down to get to that point. So if the scale factor is a half, I'm doing half of 2 down, which would be this point, which is the y-intercept, which is 0, 5. So the y-intercept is 5. The slope is negative 3. Y equals negative 3x plus 5. So we're going to do just one more together, and then I'm going to let you practice on your own. Let's do number 8. Line dilations, parallel, keep the slope. Get y by itself, and then tell me the slope. I'll give you about 30 seconds to do that. Y equals negative 3x minus 2. So the slope is going to be the same. Center on the line, sub x and y. Determine if the center is on the line. Do it. Take about 30 seconds. If you need more time, you can pause it. X is 2, y is negative 8. It doesn't matter which one you sub into. I'll sub into that one. Negative 8 equals negative 3 times 2 minus 2. Negative 8 equals negative 6 minus 2. Negative 8 equals negative 8. That checks out. On the line. Same B. Same B. Same M, same B, same equation. If the center's on the line, same B. Your answer, I don't need to graph anything. Y equals negative 3x minus 2. Doesn't matter what the scale factor is. If the center of dilation is on the line, same M, same B, same equation. That's the concept. So, line dilations, parallel, keep the slope. No matter what, your slope is always the same. From there, determine if the center is on the line by substituting x and y into the equation. If it is on the line, if it checks out, it's the same b, it's the same equation. If it's off the line, it's a different b. To get the equation, you would go on the graph and you would count from the center to what your to one of the points. Once you have one of the new points, you can apply the same slope. And then if it's origin, you don't have to go through this whole procedure for origin. That's the procedure we talked yesterday. You're just multiplying the scale factor in B. I hope everybody has a great rest of the day. I hope you have a productive rest of the period. If you're doing this in school right now, your classwork/homework is to finish line dilation centered at a point. And I hope, again, everyone has a great rest of their day.